Good evening, everyone. Hope you guys are doing well. Good to be back. Good to be back with you guys. Welcome to this learning space session this evening. We're going to be doing physical science paper two prep. We're going to be working through a past paper. How this will work, if you were here for the math sessions last week, you will know we'll spend 2 days covering paper two, that's today and tomorrow. And then you'll be with another member of our team covering paper one on Wednesday and Thursday. So you guys will see me for today and tomorrow. Awesome, guys. Just again, quick ground rules and house rules. Remember, ask lots and lots and lots of questions. This is your time to ask, right? The benefits of joining live is that you can interact with your presenter. You can ask us questions and we will answer them. Welcome to the guys that are joining us on Zoom and all the guys joining us on TikTok as well. Massive hello, massive welcome there. Um, just a quick heads up. Morabile, I don't have TikTok open on my side. I'm not sure who's doing admin on my end, but if you don't mind just sort of giving me a nudge if there's like engagements on TikTok. I'm going to try get my TikTok feed up on my phone just now as well. Awesome. The next one is that we've got multiple ways of interacting, right? So number one, how you guys can interact. There's a Q&A function in the on this webinar. So if you go to the Q&A, you can ask a question there, type it up. Please remember, use your Q&A if you want to ask me questions that are unsolicited, right? And then if you see that the question has been asked already that you wanted to ask, there's a little thumbs up, which means to upvote. It means I want to ask the same question. Just click that as well, because then it tells me that this is quite a popular question, and then I'll address it quite urgently. Now, as the lesson goes, I'm going to ask you guys to interact with me various ways. I'll ask you questions. And whenever I ask you questions and you want to respond to my questions, use the chat feature, right? So the chat is where you guys respond to me. The Q&A is if you have questions for me. And the reason why I say that is that the chat tends to get very busy in the lesson. If you post a question in the chat, I might just miss it. So the Q&A is just for questions. So then whenever I pause for questions, the first thing I'll check is the Q&A for any questions. But if you're giving me a response, I'll say, hey, what's the answer to this question here? Use the chat function to give me your answers back. And then finally, what I'll also do sometimes is that if you are keen to ask your question live, or maybe you've asked your question, but I didn't quite understand what the question was where it was going, I might just ask you to unmute, and then I'll give you the permission to unmute, and then you can just ask your question live. That also just does help as well, just to make things move quite along. I'm going to try my very best to get through half of the paper today and then the next half of the paper tomorrow. Usually there is enough time depending on how the session goes. Fantastic. Hope that makes lots of sense. So what I want everyone to do now, if you're with me, I want you guys to post a chat, an emoji in the chat, right? Give me an emoji that tells me how you guys felt about your maths paper two paper today. So quickly post in the chat. How did you feel about maths paper two? Put that in the chat there. If you want, you can even write words. Just tell me how you felt about maths paper two, the paper that you guys wrote today. If you're an IEB learner, you probably wrote what did they write today? They wrote maths last week, science paper one, IEB, but maths paper two for most of our DBE learners. Gavin says it was okay, just thumbs up. Everyone else is still thinking about how you felt. If you've just joined us, quickly post in the chat. How did you feel about maths paper one? Mpe says it was okay. Thumbs up. Okay, I'm glad. Sounding positive. Sounding positive. Okay, let me wait for a few more responses. Right, give me an emoji. So also what I really appreciate is getting creative, right? Thumbs up is good, but give me like if it was really awesome, give me a dancing emoji, give me a fire emoji, give me fireworks emoji. If you're a little bit confused, give me a frog emoji. So get creative. I like creative responses. There we go. Thanks, Gabito, for that one there. All right. Latonya says it was fair. Female says paper two was better than paper one. That's good to hear. I heard paper one was quite decent. And then Tolagala says it was okay, but I need to redeem myself with physical science. And yeah, with me there, hopefully you'll be able to redeem yourself with physical science as well as the rest of the learning space team, because everyone in the team is super awesome and super amazing. Fantastic, guys. While I wait for the other responses, let me quickly get my screen share up and then we can get started as soon as possible. Okay, I just want to share my whiteboard with you guys quickly. All right. Okay. That is up now. What I'm going to do is I'm going to switch my video off until the end of the lesson, and I'll put it back on towards the end again, right? Just to save everyone a little bit of data. Fantastic. All right. So we're doing our final exam prep, which is quite critical, guys. And with this final exam prep, I really want to get you guys improving those marks. I hope you guys have been doing lots and lots and lots of past papers. It's very, very important, right? So attending lessons is great, but you need to do practice yourself, which is even more important. So I hope that's been happening. And then today shouldn't be the only past paper you do and you sit and do that with me, right? So let's jump straight in. I like doing multiple choice questions. I don't leave multiple choice out. I think it's very important when it comes to testing one's knowledge, right? So how I'm going to do this, I'll put the question up, the multiple choice. And then what I want you guys to do is to give me what you think the answer is, how you'll do that. So you see, I've got question 1.1 up. I want you to post in the chat, type 1.1, and then put your answer A, B, C, or D. So if you think the answer is A, you'll type 1.1 A. And then we'll all go together and I'll see what the answers look like. When I'm done, I'll do corrections with you guys. And the way I'll do corrections, you'll see is quite important. This is how I want you guys to tackle multiple choice is don't just say, I think this one is correct. Give yourself reasons why the other ones are incorrect. That's the best way to do multiple choice. And when you'll see, as you do that, it really shows you where your gaps are in knowledge so that when you're in between past papers and you're busy practicing individual content, you know where to focus. That's why I love multiple choice so much. All right, awesome. So let's get going with that one there. Question 1.1 says, how many types of van der Waals forces are present between the molecules of CH3, CH2, Br? So how many types of van der Waals forces are present between the molecules of CH3, CH2, Br? If you think it's 1, you'll type 1.1a. If you think it's 2, you'll type 1.1b. If you think it's 3, you'll type 1.1c. If you think it's 4, you'll type 1.1d. I want you guys to quickly put that down there, put that in the chat, and then I'll give you guys 2 minutes with that question. Then we'll do the corrections together. Thanks, Sonala, there for your quick fingers. Sonala, you wrote 1.2, so you just specify which one you want. So it's write 1.1 and then write A, B, C, or D. Thanks, Gabeto, for your answers there. And again, guys, I do encourage you guys to put your answers in the chat. So reason why I encourage you to do this, don't worry about whether you're right or you're wrong. No one in this webinar knows who you are, first of all. Second of all, if I know where, even if you made a mistake, if I get a sense of what your mistakes are, I'm better able to help you. If I don't know where you are, I can't really help you, and I just assume you're with me. So there's a lot of honor in getting a question wrong, right? Because when you get a question wrong, it tells me quite a lot about your misconceptions. And I'd rather than come and fix those misconceptions. You don't want to find yourself on Friday or on Monday putting those misconceptions down for a matric paper that's going to be like on your record forever. So let's make the mistakes in class where I can correct you so that when you get to the exam, you don't make the mistakes. So I want to encourage you guys, please, please, please put down your answers in the chat and then I'll help you guys be able to solve and get the right ones. Cool. You got 30 more seconds for this question. Thanks, Latonola, for your answer there. Okay, 15 seconds left, guys. Please remember, never leave a multiple choice question blank. If you guess, you've got a 25% chance of getting it right. If you leave it blank, you've got a 100% chance of getting it wrong. So remember, you guys did probability. Was it last week? Yeah, it was last week, Friday. So 25% of getting chance of getting it right versus a 100% chance of getting it wrong. I'll always take my chances. So never leave it blank. 5 seconds left. If you're unsure, just guess. Put an answer in the chat. Just guess. Okay, and while everyone's done that, if you've put your answer in the chat and you've got a friend who you know will really benefit from these sessions, remember, guys, we don't even charge money for these sessions right now, right? We've got sponsors and other great people who come together to make these happen for you guys. So please make sure to just send a text to your friend, say, hey, here's the link for this lesson. Please join. It's going to help you for your exams coming up Friday and Monday. The link is in the chat that you can just forward to your friends. Okay, 5, 4, 3, 2, 1. Thank you for those that were brave enough to put their answers down. For the rest of you guys that left it blank, I want to encourage you guys to do more next time, right? There's no time to be shy when it comes to passing physical science. There's no ego or anything. Let's just do the work and let's make sure we get to pass, right? So let's look at the questions. So first of all, it says what type of van der Waals forces are present between the molecules of CH3, CH2Br? Let's first quickly draw it out. That's what I would normally do. So I've got CH3 like that. I've got CH2, and I've got bromine here at the end. Okay, so when we think about van der Waals forces, you must think about your London forces. You must think about your dipole-dipole forces. These are all your intermolecular forces, right? So London forces happen when you've got non-polar molecules interacting with non-polar molecules. Dipole-dipole happens when you've got polar molecules interacting with polar molecules. So that's when you're dealing there with polar covalent bond and an asymmetrical distribution of charge. Those are your polar molecules. So the nice thing about these haloalkanes, they will have two types of intermolecular forces. So on this side here with all the H's, you're going to have your London force, right? And on the other side, on this side here with the Br, you will have a dipole-dipole that you can then interact. So that's basically how you will have that set up. So in that case there, we've got London and dipole-dipole. That is going to be two types of intermolecular forces. So the correct answer is B, two intermolecular forces. If you got that question right, please give yourselves a reaction in the chat, give yourselves firework emoji, dancing emoji, whatever it is to celebrate yourselves. But if you got it wrong, but you see now how to do it, that is cause to celebrate as well. So jump in there, celebrate with everyone else because you are learning, right? Like I said, nothing wrong with getting things wrong. What's important is learning. And oftentimes, if I see someone that maybe chose A, is because they thought, no, listen, normally we're told alcohols will have your hydrogen bonds and carboxylic acids with hydrogen bonds, and they tell you your hydrocarbons will just have London forces. But remember, if you've got a haloalkane, right, that halogens, this is group 7. They normally have a very high electronegativity in group 7. So you'll be able to have dipole-dipole intermolecular forces on that side of the molecule because that side of the molecule becomes slightly negative. The other side of the molecule becomes slightly positive, right? Which becomes then important in that case there. So that's a good thing to check out. Awesome. Hope that it went well. Thank you to Tonelo Tonelo and Mosa for celebrating. You guys are really awesome. Thank you for your interaction. Let's jump to question 1.2. Okay, so 1.2 looks as follows. It says, which one of the following is the correct formula for methyl butanon? Which one is the correct formula for methyl butanon? So first thing I want you to think about, what is methyl butanon? How can you see if something is a methyl butanon and then look through those there? So what kind of organic compound is this? I'll give you guys 2 minutes to quickly try to do this one. Remember, post 1.2 and your answer in the chat. So if you think it's A, 1.2A. If you think it's B, 1.2B. If you think it's C, 1.2C. If you think it's D, 1.2D. Give it a bit of a think, have a look at it. If you need to draw it out for yourself, and then put your answer in the chat. You've still got a minute and 40 seconds. Thank you, Kuba, for your quick fingers there. Remember, guys, if you've got questions during these, while we're doing this, you're more than welcome to ask me questions when you have these problems. Use the Q&A function to ask those questions. And then what will be left, if there are questions on TikTok, do you mind just posting them in the Zoom Q&A for me, just so I can respond to our TikTok family there? Okay, you guys have 1 more minute left. Thanks, Ratabile, for your answer there. Thanks, Busiso, for your answer. If you've just joined us on TikTok, we're busy with question 1.2. We're going to do corrections together just now. Quickly just post your answer in the chat. Okay, 20 seconds left, guys. If you are unsure, this is your time to just guess. Remember, never leave a multiple choice question blank. Thanks, Keviso, for your answer. Thanks, Mosa, for your answer. 5, 4, 3, 2, 1. Awesome. So which one of the following is the correct formula for methyl butanon? So again, methyl butanon, the first thing I'm going to look for there is that non, right? That non tells me I'm dealing with a ketone, right? I'm dealing with a ketone. Then but says I'm dealing with a ketone that's got 4 carbons in it. And then this says I've got one CH3 group attached, right? So let's look at all the ones. So A there, we can see that's going to have an OH. So this OH says an alcohol, not a ketone, right? Then we've got B has HCOOCH. That looks more like a carboxylic acid or an ester, right? So it can't be that there. C has my O right at the end, right? And at the end, it's not a ketone. I'm dealing more with an aldehyde. So that's not going to be C there, meaning D is going to be my ketone because the O is in the middle. But let's also double check how many carbons do we have there? So we've got 1 carbon, 2 carbon, 3 carbon, 4 carbon, and then we also have a CH3 group that's in the middle. So D becomes our correct answer. If you guys got that question correct, give yourselves an awesome celebration in the chat. If my unpacking of the answer makes sense to you, if how I explain the memo makes sense to you, you can also celebrate because it means you've now learned as well how to do this question next time. Okay, I'll give you guys 10 seconds to celebrate, and then we're going to jump on to question 1.3. Okay, question 1.3 says, a compound CH3CH2 times 5 and CH3 undergoes the following reaction. So that's CH3, CH2 times 5 and CH3. What is that? That's 1, 2 plus 5, 7. Heptane undergoes that reaction. It creates compound R plus CH3, CH2 times 2 and CH3. Which one of the following combinations correctly describes the type of reaction and the IUPAC name of compound R? Okay, simply put there in the chat, 1.3 plus your answer. Is it A, B, C, or D? Remember, guys, don't just say, I think this is correct. You must also prove to yourself why you think the ones that aren't correct aren't correct. Thanks, Kamo, for your quick fingers there. Thanks, Timbile, for your quick fingers. Everyone else, you've got about a minute left. Thank you, Tandy, for your quick fingers. Thanks, Tolegeda, for your quick fingers. Everyone else, you've got 30 seconds left. If you're still very much unsure, this is the chance to guess. Thanks, Kiyan Letlogonolo. Okay, 10 seconds to go. Quickly just put a guess in the chat. Don't leave it blank, guys. If you leave it blank, you're guaranteed to get zero. 5, 4, 3, 2, 1. Awesome. Let's have a look at this one, right? So we've got a molecule there, CH3, CH2 times 5, and CH3. So that's going to be 5 plus 1, which is 7 carbons. That's going to be heptane. And then it gives us R plus CH3 times plus CH3, I mean CH2 times 2 and CH3. So that's going to be 2 plus 1, which is 4. So I can already see there that R, all right, has lost a certain number of carbons as well. So I went from 7 carbons. The next thing has got 4 carbons. There's 3 carbons that have to be somewhere. So the 3 carbons will be with what my IUPAC name will probably be pane or propene. Let's just double check which one it is based on the the bonds, right? So also what type of reaction is this? So now we took one long molecule and broke it down into two smaller molecules, right? What type of reaction is that? That's called cracking. Remember, when we're dealing with elimination or addition, the number of carbons don't change. What you might change are the side chains. The number of hydrogens will change. I'll add an oxygen or I'll remove a halogen, but the number of carbons don't change. If my number of carbons change, I go from one big molecule to two smaller molecules. That's called cracking. So immediately I know that my answer is not A and it's not B. It's either C or D. All right. Then from there, I need to try to figure out, is it propane or is it propene that remains, right? And usually when you are cracking, especially if you start with an alkane, you have to end up with one alkane and another alkene, right? So CH3, CH2, CH2, CH3, 1, 2, 3, 1, 2, sorry, 1, 2, 1, 2, 3. This is already my alkane, right? Meaning the other one has to be an alkene. So it's not going to be propane, it'll be propene. So C is not the right answer. The correct answer will then be D. If you got the right answer, please do the best celebration that you can do in the chat. If you didn't get the right answer, but you see where your mistake was and you now understand how to do this question next time, jump in, celebrate as well, because learning for me is better than getting something right in the first place. Cool. Awesome. I'll give you guys 10 seconds to celebrate, and then I'm going to jump on to question 1.4. All right. Question 1.4 then says, two gases are added into each of the four empty containers at the same temperature, right? So the gases there will be the black gas and the white gas. The diagrams below show the molecules of the gases and the volumes of the containers at the start of the reaction. In which one of the following containers is the initial reaction rate the highest? A, B, C, or D? Quickly, we just put down 1.4 and your answer A, B, C, or D. I'll give you guys 2 minutes to quickly look at this one. Okay, 30 seconds left, guys. Just quickly start getting your answers in. Thanks to Kiabetsu and Tolagela for your quick fingers there. Okay, 10 seconds to go. 5, quickly guess, throw your answers in the chat. 4, 3, 2, and 1. Okay, let's have a quick look at this one. So we're given the scenario here. There's two gases. The two different gases is going to be this gas here and that gas there. Added to 4 different vessels. 2 of the vessels have a volume of 5 cubic centimeters. Then the third one has got 10. The fourth one has got 20 cubic centimeters. Now, what's going to determine the highest reaction rate? All right, let's think about our factors affecting rate of reaction. So concentration, pressure, temperature, nature of reactants, catalysts, all of those. Based on this, all we can really tell is pressure, simply by looking at number of moles per unit volume, right? So in this case here, the concentration of gas A, let's call the white one gas A and the black one gas B. The concentration of A is going to be 4 moles per over 5 cubic centimeters, right? So I'll just do it in moles per cubic centimeter because that's what they've given us. That's going to be 4 over 5. B here has what? 3 over 5 moles per cubic centimeter. Let's look at V2. So A will have 3 over 5. B will have 2 over 5. That's already less than A, so I know that B can't be the right answer. Let's look at C. C, A is going to be 4, because we've got the 1, 2, 3, 4, but my volume is 10. And B, I've got 1, 2, 3, with a volume of 10. That's already also less than A, so C can't be it. Let's look at D, because D's got a lot more, right? So D, A has 1, 2, 3, 4. What's 1, 2, 3, 4, 5, 6, 7, 8. But that's out of 20, right? If we were to divide that by 4 to try and make it out of 5, like the other one, that's going to be 2 out of 5. Already A is going to be less than the one we got for A. And then let's look at B. That's 1, 2, 3, 4, 5, 6 out of 20. Divide that by 4, it's even less. So then D doesn't have as high a concentration, meaning the highest concentration we have there is going to be A, and therefore that will give us the highest rate of reaction. Hope that makes sense. If you got that right, quickly celebrate in the chat. If you didn't, but you understand what I did, give yourself a round of applause and also join in the celebrations, right? Let's jump on to 1.5. 1.5 says, which one of the following statements is true for the effect of a catalyst on the reaction at equilibrium? A, the equilibrium constant increases. B, the rate of the reverse reaction increases. C, the activation energy for the reverse reaction increases. Or D, the enthalpy change, delta H, for the forward reaction decreases. Which one of the following statements is true for the effect of a catalyst on the reaction, on a reaction at equilibrium? You guys have 2 minutes to quickly put your answers in the chat. If you are unsure, please just post in the Q&A. Suddenly, I do see your question there. I'll go back to it as soon as I'm done with 1.5. But in short, suddenly for 1.5, look at the number of moles divided by the volume. And basically, you can actually manually calculate the concentrations. And then you know, based on rates of reaction, the highest concentration will give you the highest rate of reaction. We were told nothing about temperature, so I can't use that. And because these are gases, we're actually dealing with pressure. So the highest pressure will give you the highest rates of reaction, but pressure and concentration are very similar in terms of what they are. We don't know the nature of reactants. We don't know the state of division, any of those kinds of things. But what we can compare is the pressure. And when you look at the number of moles per unit volume for each of them, A has the highest number of moles per unit volume. Okay. Thank you to Blessing, Tandy, and Tembile for your quick fingers there. Everyone else, you still have about a minute and 20 seconds to go. Okay, you got under a minute left. Quickly put your answers in the chat. 10 seconds to go. If you are unsure, just guess and put something down in the chat. 5, 4, 3, 2, and 1. Okay, let's quickly have a look at this, right? So here we got, it says, which one of the following statements is true for the effect of a catalyst on a reaction at equilibrium? So we have the A, the equilibrium constant increases. So we know that that's not true because the only thing, right, that affects the equilibrium constant value is going to be temperature, not a catalyst. Let's look at B. The rate of the reverse reaction increases. That is true because a catalyst increases the rate of reactions, both forward and reverse, right? It doesn't change the equilibrium position, but it does increase the rate of the forward and the reverse reaction. Let's look at C. The activation energy for the reverse reaction increases. That is not true. A catalyst will drop the activation energy for both forward and reverse. So that's not true there for C. D, the enthalpy change or delta H for the forward reaction decreases. That's not true. All we're doing is decreasing the activation energy required. The delta H remains exactly the same. So we can see there that B is the correct answer, and we saw what is incorrect and why those are incorrect. If you got it right, give yourself a round of applause or whatever celebration method you want to use in the chat, or your emojis. And then if you didn't get it right, but you see where you went wrong, please jump in and celebrate as well as I move to question 1.6. Okay, 1.6 says carbonyl chloride gas, COCl2, decomposes in a closed container and reaches equilibrium according to the following equation. Carbonyl chloride becomes carbon monoxide plus chlorine gas. The delta H for this reaction is greater than 0. Consider the following statements. An increase in temperature will do the following. 1, favor the reverse reaction. 2, increase the concentration of our products. 3, increase the equilibrium constant. Which of the following statements above are true? A, only 1 and 2, B, 1 and 3 only, C, only 2 and 3, or D, 1, 2, and 3 are all correct. I'll give you guys a minute to quickly put your answers down for this one. Tolagel is asking there. Tolagel, just a reminder, if you've got a question for me, please put that in the Q&A so I don't miss it, right? But I'll quickly read your question. So, sir, the effect of catalyst on the graph reduces the activation energy required 100%. So if you're looking at your energy versus progression, right? Or reaction coordinate graph, that's that graph that looks like this, right? Adding a catalyst basically reduces your activation energy down like that. You don't need to go as high. You don't need to put as much energy. But it'll reduce the activation energy for both forward and reverse, but your delta H doesn't change. Delta H is the difference between the top and the bottom there. That doesn't change. Thank you for that question, Tolagan. Thanks to Blessing and Kabetu for your quick fingers there. Yeah, you have less than a minute to go. Okay, time's up. Let's quickly look at the correct answer. All right. So when we look at that reaction over there, let's look at the following. It says an increase in temperature will favor the reverse reaction. Let's see if that's true. So first of all, what do we look at there? We look at delta H. Delta H being positive means the forward reaction is an endothermic reaction, right? So if we increase temperature, we will favor the reaction that decreases that temperature, right? So the reaction that decreases temperature is our endothermic reaction, which is our forward reaction. So an increase in temperature favors the forward reaction. So that means one is not a true statement. Two says it'll increase the concentration of the products, right? Because we are favoring our forward reaction, that means the product concentration will increase. So two is a correct statement. And because remember, we're changing temperature, temperature does change our equilibrium constant. But how does it change it? If we favor the forward reaction, we will increase Kc. If we favor the reverse reaction, we will decrease Kc. In this case, we know we favored the forward reaction, the endothermic reaction. So our Kc will increase. So 2 is correct. So in that case there, only 2 and 3 are correct. Therefore, C is our correct answer, not A, not B, and not D. If you guys got that correct, give yourselves a round of applause, give yourselves any kind of reaction to celebrate. And then if not, but you see where you went wrong, jump in the celebrations as well, because learning is happening and you're going to do much better in your final exam than you did your prelim. Okay, let's jump to 1.7. 1.7 says, consider the equation for the acid-base reaction below. So you've got that HSO4 minus plus NH3 giving you SO4 2 minus plus NH4 plus. The two acids in this reaction are, and then we're given NH3 and NH4 plus, or HSO4 minus and SO4 2 minus, or HSO4 minus and NH3, or HSO4 minus and NH4 plus. Which two of those are our acids? Gavin says, please repeat what you said about three. the increase in the equilibrium constant. So remember, only temperature changes your equilibrium constant. Remember that Kc is products over reactants. So if my Kc value increases, it means I've got more products than reactants. If my Kc value decreases, it means I've got more reactants than products. When you favor a forward reaction, and that forward reaction was favored due to a change in temperature, your Kc value will increase. And then if you favored a reverse reaction, and that reverse reaction was favored due to a change in temperature, your Kc value will decrease. Thanks, Kamukhelo and Gift, for your quick fingers there. You've got less than a minute left for this question. Okay, 10 seconds to go. Quickly guess if you're unsure. Nine, eight, seven, six, five, four, three, two, and one. Okay, let's have a look at the reaction quickly. So initially, you can clearly see there that HSO4 minus is our acid, NH3 is our base. And how you can tell is because HSO4 gave up a hydrogen to become SO4, right? So which means HSO4, sorry about that, HSO4 minus was our original acid, and that produced our conjugate base of SO4 2 minus. That's our conjugate base. Then we can also see that our original base, NH3, let's call that B2, accepted a hydrogen to become NH4 plus. That's a conjugate acid, A2, right? So the two acids in question, it's going to be our original acid, HSO4 minus, plus our conjugate acid, NH4 plus. Because when you look at your conjugate acid, if this reaction were to happen in reverse, what happens? NH4 plus gives away H plus, and then it becomes NH3. So the NH4 plus in the reverse reaction is the acid. We call that our conjugate acid if you were to go backwards. So I've highlighted our two acids, HSO4 minus and NH4 plus, meaning our correct answer for 1.7 is going to be D. And by process of elimination, C, B, and A will automatically be incorrect answers because they don't include both of our acids and conjugate acid. Hope that makes sense. If you got that right, jump in the chat, give us an awesome celebration. If not, but you see where you went wrong and you think you'll do better next time, jump in and celebrate as well. As we move on to question 1.8. Alrighty. 1.8 says the conductivity of two acids, HNO3, which is nitric acid, and CH3COOH, each with a concentration of 1 mole per decimeter cubed, is compared at 25 degrees Celsius. The simplified diagrams below show the apparatus used. The electrodes are made of carbon. So we've got two scenarios that are basically identical. The difference we have there is that the electrolytes are acid A and acid B, respectively. Which one of the following combinations correctly describes the brightness of bulb A and bulb B and provides the reason for this? Okay, quickly just post 1.8, either A, B, C, or D. You've got an hour, I mean, an hour, sorry, you've got a minute and about 40 minutes, 40 seconds remaining. Thank you for the quick fingers coming in there. Less than a minute left for everyone else. If you are incredibly unsure, the worst you can do is just to guess. At least just try a guess. Okay, 10 seconds to go. 5, 4, 3, 2, and 1. Okay, 1.8 says the conductivity of two acids, HNO3 and CH3COOH, are compared. We need to see what the difference in the brightness of the bulbs is going to be and the reason, right? So looking at that there, we need to think about, well, what would make the bulbs shine differently, right? So that we have to think about the conductivity of each of those acids. Now, conductivity is determined by how many ions you will have in solution, right? And the number of ions you have in solution is determined by how completely your acid will ionize in solution. So again, remember, strong acids ionize completely, whereas weak acids ionize only partially. When looking at nitric acid is relatively more of a strong acid than acetic acid there. So in the case where nitric acid will have more ions in solution than acetic acid, meaning nitric acid will have more ions in solution, and as that happens, your conductivity will increase, your bulb will shine brighter versus the acetic acid. So immediately there, I know that bulb A will be brighter. So I know that the answer, um, sorry, you can quickly get a red pen there. Bulb A will be brighter than B. So I know that it's not going to be C and they won't have equal brightness. It won't be D. So it'll be either be A or B. And we need to figure out because one is a stronger acid than the other. And in this case, nitric acid is a stronger acid than your acetic acid. So your answer there will not be A either. It will just be B. Okay. So if you got that right, give yourself an awesome celebration in the chat. If not, but you see where you went wrong, please jump in the celebration as well as we do 1.9, our second last multiple choice question. Okay. 1.9 says, which one of the following combinations of temperature and pressure is correct for the standard hydrogen half cell? I'll give you 30 seconds for this one. You don't even need that much time. What's the correct combination of temperature and pressure for the standard hydrogen half cell? In simple terms, they're asking, what are standard conditions for the electrochemical cell? 15 seconds to go. 10 seconds. 5, 4, 3, 2, and 1. Remember, for your standard hydrogen half cell, you're looking at standard conditions for the electrochemical cell. That's going to usually be a concentration of your electrolyte needs to be 1 mole per decimeter cubed. The temperature needs to be room temperature, 25 degrees Celsius, not 0. Don't confuse standard conditions with standard temperature and pressure. That's STP. That's different. So it'll be 25 degrees Celsius. So already I know that it can't be A, it can't be D. And the pressure must be 1 atmosphere. And what 1 atmosphere of pressure is 101.3 kilopascals. So we know that it also can't be B. 273 is quite high. So it will end up being C as the correct answer. Nice and easy one. If you got it right, jump in the chat and give us an awesome celebration. If you didn't, but now you see where you went wrong and you'll remember it next time, jump in there and celebrate as well. Let's jump on to our final question for multiple choice before we do our long questions. So our final question there, 1.10, says impure copper is refined in an electrolytic cell. Which one of the following combinations correctly identifies the anode and the electrolyte for this cell? So choose between A, B, C, and D to determine which anode will be there for impure copper being refined and what electrolyte would you use. You've got a minute and about 40 seconds left. Okay, you have a minute left. 30 seconds to go. Okay, 15 seconds to go. If you're unsure, this is the time to just guess. Take an educated guess. Maybe like you rule out one or two and then at least take a guess between the last two. 5, 4, 3, 2, and 1. All right, let's have a look at this 1.10 quickly together. So when we're refining copper, right, remember we want to take impure copper and then oxidize the copper ions into solution, then reduce the pure copper ions onto copper metal, right? So at the anode is where the oxidation needs to take place, right? So we're going to oxidize the impure copper, right? So already at that point there, I know it's not going to be A, it's not going to be B, it'll be C or D. Now, which one between C and D? Someone once, gave this way of doing multiple choice questions that will make it easy for you guys. He says, number one, with multiple choice questions, they usually put the answers in two batches. So like here, you had two of them are pure, two of them are impure. You might not know the final answer, but you'll know at least enough that these two aren't correct. And then it leaves down to the last two. And when it's the last two, it stops becoming multiple choice. And now it's like a true or false. Just pick one and say, is this true or false? Right? So again, we know it's impure copper. Now the electrolyte needs to have copper in it for you to be able to reduce copper onto the solution. D has silver, which is not going to be what I want. I want copper nitrate as an electrolyte. So D doesn't become an option. C becomes the right answer. If you got that correct, please celebrate in the chat. If not, but you see where you went wrong, jump in, celebrate because you're learning, and it means you're going to do better in your finals and your prelims. That's the only thing we want to aim for. Every single day, improve by 1%. And you'll be surprised how far you'll get if you just do that, right? That brings us to the end of our multiple choice questions. Next up, we're going to do some long questions, starting with question 2, and I'm going to work my way down. So please note, I'm working my way down from 1 to 2 to 3 to 4, just to show you guys how each of these things work. But I don't recommend you guys do that in your exam. You already know which topics you're better at than other topics. So in your exam, you must start with the topics you're most confident with. Always, always do that. So if you know that, listen, organic chem is your strongest topic, skip the multiple choice. Go straight to question 2. Start working with organic chem. If you know it's electrochemistry, skip everything. Go right to the end. Go start with with electrochemistry. So start with wherever you're strongest. It keeps your confidence very high throughout the session, right? So let's jump into question 2. And question 2 looks as follows. It says the letters A to F in the table below represent organic compounds. And we see the A, B, C, D, E, and F. 2.1 says define the term unsaturated compound, right? That's a nice, super easy one. So the unsaturated compound, let's put our answers on the next page here. 2.1, an unsaturated compound, right? These are compounds that have one or more multiple bonds between carbons. So it'll have a double or triple bond, and they'll have more of those. So it's compounds with one or more multiple bonds. Multiple bonds is a double bond or even a triple bond between carbon atoms. Okay, nice and easy, nothing hectic. It's just compounds with one or more multiple bonds between carbon atoms. That's 2.1. Let's look at 2.2, right? 2.2 says, write down the letter that represents each of the following. So 2.2.1, they want an unsaturated compound. I want you guys to put that in the chat for me. What letter represents an unsaturated compound? Quickly just put your answers in the chat. Thank you, Spusiso, for your quick fingers there. 10 more seconds. If you're unsure, just guess. Never leave it blank. 5, 4, 3, 2, 1. So when we look at these molecules there, right, A, if you look at the ratio of carbons to hydrogens, etc., A, B, C, D, and F will all be saturated, right? E will be unsaturated. And how do I tell? I can see there I'll have CH2, C, and then two CH3s. So that C in the middle tells me that this is going to be unsaturated because you're going to have a carbon attached to just another carbon attached to another carbon. So in between there, you would need to have either a triple bond on one side and a single bond on one side, or double bonds on either side. So E becomes the one that's unsaturated in that case. There, 2.2.2, write down the letter of something that represents a functional isomer of compound C. So quickly give me that in the chat. What letter represents the functional isomer of compound C? Compound C is that butanoic acid. Thank you, Mpo, for your quick fingers. Thank you, Sbu. Thank you, Tolagele. Okay, let's wrap that up again, right? So again, those that wrote letter F, well done, that is correct, right? Functional isomer of compound C. Compound C is butanoic acid. It's a carboxylic acid. Functional isomers of carboxylic acids will usually be esters, right? So F is going to be our ester. So that's going to be 2.2.2. Well done for those that got it right. Let's look at 2.3. 2.3 says, name the two homologous series to which A belongs, right? So there's two homologous series to which A belongs. And then why did they say two homologous series? Because A can have two functional isomers, right? So 2.3, let's first look at what that is. CH5H10O. That should give you a very good hint there as to what that could be. So 2.3, this can either be a ketone or it can be an aldehyde. Right? That's what it could be. My question would be, so thank you, Paul, there, you got that right as well. Why can it not be an alcohol? Because in this case here, you're going to have one less hydrogen. For it to be an alcohol, would have had to be C5H11O. That would be a hydrogen. I mean, not a hydrogen, an alcohol. But because I only have 10 hydrogens, it means I'm going to have a double bond for my oxygen. In that case, it has to be a ketone or an aldehyde. Awesome. 2.4. 2.4 then says to us, is compound D a primary, secondary, or tertiary alcohol? Give a reason for your answer. Let's look at compound D. Compound D is going to be CH3 times 3 COH, right? Let's have a look at what that would look like. CH3 times 3 and COH would look like this. That's 2.4. So you'd have a CH3 times 3 CH3. That's the second one. CH3. That's the third one. And then finally, we've got the COH. That's how you draw that. And again, remember, a primary alcohol is where your hydroxyl group, your OH, is connected to a carbon that's connected to one other carbon. Secondary alcohols is where your hydroxyl group, your OH, is connected to a carbon that's connected to two other carbons. A tertiary alcohol is where your hydroxyl group is connected to a carbon that's connected to three other carbons. So because we can see here, the carbon, sorry, didn't mean to do that. The carbon with the hydroxyl group there is attached to one, two, three other carbons, meaning this will have to definitely be a tertiary alcohol. Nice and easy. Drawing it does help quite a bit, and it helps it make a bit more sense. All right. Okay, let's look at the next question, 2.5. 2.5 says, write down the IUPAC name sorry, by the way, Kamokhelo, well done. You got that one correct. 2.5 says, write down the IUPAC name of compound B. Compound B, we can see is sitting over there, right? And compound B, we need to first go and find the longest chain in any side chains that might exist there. So let's quickly find what are the longest number of carbons in compound B. Quickly put that in the chat. I'll zoom in. Have a look at compound B. What's the longest carbon chain that we have there? Quickly post in the chat. What's the longest chain of carbons we have in compound B? Thank you for your answer, Kamkhelo there. Let's look, right? So if I went 1, 2, 3, 4, 5, 6, that would work. Could I also do this? Could I also go 1, 2, 3, 4, 5, 6? It will also work. Same molecule, right? Not much of a change. So let's maybe stick with the straight one as my main chain. So here's my main chain over there. Okay, then what are our side chains? Side chains, let's see, what do we have? I've got an iodine there. I've also got this ethyl group. Remember, I've got two carbons on the side. It's not a methyl group, it's an ethyl group. Then we have to start numbering from the carbon that's closest to our functional group, right? And then in order to do that, I've got a side chain there and I've got my iodine, right? In this case there, because my iodine is like 3 from the right, but my ethyl is 3 from the left, I'm gonna use the alphabetical order for us to do this there. So I'll then have 1, 2, 3, 4, 5, 6, and then I can start naming. So I'm gonna have 6 carbons, which is gonna be hex, all single bonds, ane. So I'm dealing with a hexane. What side chains do I have? I've got an ethyl group at carbon number 3. I've also got iodine at carbon number 4. So I'll have a 3 ethyl, 4-iodohexane. Let's quickly go write that down. That's question 2.5.1. So that is going to be 3-ethyl 4-iodohexane. Awesome. Nothing too hectic. Let's look at 2.5.2. It says, what's the positional isomer of compound D? Let's look at compound D. Compound D, all right, is that tertiary alcohol that we're looking at there. And now they want us to know what the positional isomer of that thing will be. I'll give you guys 2 seconds to quickly try post that in the chat while I quickly look at some of the previous answers. Hexane, 3-ethyl hexane, 6 carbons from the top, well done. 4-ethyl 3-iodo, hexane 3-ethyl 4-iodo hexane. I'll remember alphabetical preference. Okay, thank you there, Mpo. Okay, cool. Now we need for D, we need to know the IUPAC name for the positional isomer of that there. Let me quickly redraw this. It's going to be D. 2.5.2. We need the IUPAC name for the positional isomer for this here. Okay. Now for a positional isomer for this, all you need to do there is simply take your hydroxyl group and swap it with one of these hydrogens. And then you move your alcohol from carbon number 2 to carbon number 1 or 3, but 3 still becomes 1. It doesn't become 2, right? And in this case here, you still have 3 carbons in my main chain. That's prop. It's an alcohol, propanol. You've also got 2 side chains. Side chains are going to be, sorry, that's not a side chain there. That's your functional group. Your side chain is going to be this methyl group that it comes up here. Here's a side chain there. So let's quickly put that name together, the IUPAC name. So again, starting with your side chains, and then let's number the number of carbons. That's carbon number 1, number 2, number 3. So we have a methyl group at carbon number 2. So we end up with 2-methyl, right? And the molecule is a propanol. And then because we have to specify where the hydroxyl groupers, you can go prop dash 1 dash all, or you can say 2-methyl, 1-propanol, or you can say 2-methyl dash propan 1 all. Any one of those will be accepted, right? Okay, some guys wrote butanol. Remember, it's not butanol because I don't have 4 carbons in a straight line. I only have 3 carbons in a straight line and a side chain, a methyl side chain. I hope that makes sense to you guys there, right? Fantastic. 2.5.2 is done. Let's jump to 2.6. 2.6 says ethanol reacts with compound C to form an organic compound Z, right? Let's see, compound C is butanoic acid. So we've got ethanol, which is an alcohol, reacts with carboxylic acid to form an organic compound, Z, right? Write down the type of reaction. So when I've got an alcohol and a carboxylic acid coming together, right? What kind of reaction is that? That's quite easy. It's esterification. And then they want the structural formula for compound Z, 6.2.6.2. So let's quickly have a look. We have ethanol reacting with compound C. Compound C is butanoic acid and ethanol. That's 6.2.6.2. 2.6.2 ethanol plus butanoic acid, right? So they want the structural formula for that. So let's start with our ethanol. Ethanol becomes C dash C dash OH. Hydrogens there, hydrogens there, hydrogens there. Then we also have our butanoic acid. That's going to be 1, 2, 3, 4 with double bond O and OH, and then hydrogens everywhere else. When these two things come together, here's what happens, right? You have one of your OHs and the other H comes off, and that's going to form water, H2O. And then the rest of this comes together, and that's what forms your ester, essentially, right? And that's basically how your ester will look. So make sure you've just got all of those there. The functional group is very important, and the number of carbons in the whole structure being correct is how you get your second mark. Hope that makes sense to everyone when those two things come together. That's 2.6.2. 2.7, 2.7.1 says, write down the empirical formula of compound F. Let's look at compound F. Okay. Compound F has, let's count the number of carbons. It's 1, 2, 3, 4 carbons, right? That's going to be C4. Let's count the number of H's. H's is going to be 1 plus 3 is 4 plus 2 is 6 plus 2 is 8. That's H8. Let's count the number of oxygens. 1, 2, 2 oxygens, right? Now, they said we need to find the empirical formula, right? The empirical formula, remember, what we need there is the lowest ratio of those. That's 2.7.1. So the lowest ratio of C4H8O2, if we find the lowest number, and then if we can divide every other number by the lowest number, then we win. So the empirical formula then becomes C2H4O, and there's our empirical formula, right? Almost done with organic nomenclature. 2.7.1 says, find the structure, write down the structural formula of the chain isomer of compound E, right? Let's quickly figure out what is compound E, then we can move from there. 2.7.2, compound E is at CH2C, CH3 times 2, and we need to find the chain isomer of that, right? Let's quickly put that down. CH2C, CH3 times 2. Let's write that down. Sorry, my rabbit brain has already forgotten now what that molecule is. Compound E. CH2C, CH3 times 2. Times 2, right? That's what we got there for set 2.7.2. So let's first draw what this molecule would look like. So you got C, H2, Then you're going to have a carbon there, right? And then it says CH3 times 2. Let's see how the CH3 times 2 would be. Let me see if they wrote this correctly. It's compound ECH2, and then C with 2 CH3s. Okay, I see it now. So I basically have a CH3 here and a CH3 there. And then I'm missing another bond there. That's what I've got there. Okay. So that's basically like methyl propene, right? So we need to find a chain isomer. So chain isomer means, so what I'm going to do, I'm going to just draw this slightly differently so that it just makes a bit more sense when we're looking at it visually. Let me do that. That means when we're looking at this, here's my main chain here, right? My propene, and I've got a methyl group coming off the end. Now, there, chain isomer means I need to move my functional group, right, to a different position completely. There, sorry, not to a different position. That's a functional isomer and a positional isomer. What I need to do here, chain isomer means I need to have this molecule with a different chain length. My current chain length is 3. So to get a new chain length, I just need to then get this to a chain length of 4. So if I take this side chain and I move this side chain all the way there, then that's going to become your functional isomer. I'm missing one hydrogen there, and then that's complete. Make sure when you do this, all your carbons have 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds. Then everything should be sorted. That's a chain isomer for the molecule that we were dealing with. Okay, hope that makes sense to you guys there. Nothing in the Q&A so far. The chat seems to be okay. That is organic nomenclature, right? Nothing too hectic, nothing too serious. That's question 2. I'm going to pause for questions. If there are no questions, I'm going to jump onto question 3. Okay, I think everyone seems to be doing well. Let's jump on to question 3. All right, question 3 is as follows, right? Question 3 then says, the boiling points of straight chain aldehydes and straight chain carboxylic acids are compared. The table below shows the results obtained. So we've got number of carbon atoms in the compound, 1, 2, 4. Then investigation 1 finds that the boiling point of the aldehydes goes from negative 19, 20, 49, 75. Investigation 2 finds that the boiling point of carboxylic acids, same number of carbon atoms, 101, 118, 141, 164, right? 3.1.1, define the term homologous series. So homologous series is super simple. It's a series of organic compounds that can be described by the same general formula. Let's quickly put that there. Sorry. A series of organic compounds that can be described by the same general formula. Right, that's going to be useful there. Or you can say a series of organic compounds where one member differs from the next by a CH2 group, right? That's how you can then define a homologous series there. Okay? Or a bunch or group of organic compounds that have the same functional group, essentially there. So 3.1.2 says write down the name of the functional group of the aldehydes, right? Let's quickly put that in the chat. What is the name of the functional group of the aldehydes? If you know, quickly pop it in the chat. Thank you, Paul, for your quick fingers there. It's the formal group, right? It's that O, double bond O at the end. It's the formal group, FORMYL group. Okay, B says, what's the IUPAC name of the compound with the highest vapor pressure in this comparison? What has the highest vapor pressure in this comparison? So remember in this case here, the compound with the highest vapor pressure is going to be the same compound with the lowest boiling point, right? So the lowest boiling point we can see exists in this space here. It'll be an aldehyde with a single carbon, right? One carbon is meth, and aldehydes end in anal. So methanal will be the thing that we're dealing with. So remember here, your boiling point and vapor pressure will be like inversely proportional. Usually the higher the boiling point, the lower the vapor pressure. The lower the boiling point, the higher the vapor pressure. So when they're asking us which is going to have the highest vapor pressure in the comparison, so the highest vapor pressure, I'm going to find the lowest boiling point, which exists over there. That's an aldehyde with a single carbon. One carbon is meth, and then an aldehyde is going to be anal, methanol. Okay, hope that makes sense there to you guys there. Okay, then it says 3.1.3. For investigation 2, write down the controlled variable. What do you guys think the controlled variable is for investigation 2? Thank you, Stimbila, for your answer there. I'll give you guys 15 more seconds. Okay, so thank you, Mpo, for your quick fingers there as well and your answer. All right. Thank you, Gift. So yeah, so the control variable for investigation 2, we're comparing the boiling points of carboxylic acids. So the one thing that we must keep the same is the fact that everything we're dealing with must be a carboxylic acid. So you can say homologous series, functional group, those kinds of things. There's other control variables like atmospheric pressure, there must be straight chains, a type of intermolecular forces. But the two main ones there you're dealing with is your homologous series and functional group. The reason why it can't be temperature is because we're measuring at which temperature this thing boils. So temperature in this case here becomes a dependent variable, not necessarily a control variable. Very, very important. So the control variable, the two important ones for me, homologous series or functional group. Awesome. Then B says, describe the trend in the boiling points. And then when we look at there, we can see investigation 1 and investigation 2, sorry. As I go down, my boiling point increases, both sides. And the important thing there is, as my number of carbons increase, my boiling point increases. So we can see there that my boiling point will increase with an increase in chain length. So my BP will increase with an increase in chain length. Very important. Boiling point will increase with an increase in chain length. Then C says, fully explain, right, the answer that you gave in question 3.1.3b. So basically what they're asking for is, why is this the case? So let me quickly put that down there. That's 3.1.3c. So why is it that as our chain length increases, the boiling point increases, right? So one thing that's very important there to note is that as the number of carbon atoms increases, right, or my chain length increases, certain things happen. So number one, you're going to increase your surface area for the intermolecular forces to act, or your contact area. Also, your molecular mass will increase. Um, and that means that the strength of your intermolecular forces was going to increase as well, right? Because you need more energy to break them apart. And that essentially becomes your answer. So we'll write there, as the C atoms or my chain length increases, the the surface area that we're dealing with there, right, or the contact area increases. And this, number one, requires more energy to break because the strength of the intermolecular forces also increases. So the strength of the intermolecular forces increases. And this requires more energy to break the bonds or to overcome the intermolecular forces. Not necessarily break the bonds, right? Okay, that's 3.1.3. Let's quickly have a look at 3.1.4. 3.1.4 says, write down the boiling point of butanol, right? So butanol, what is butanol? So let's quickly look there. The null tells us we're dealing with an aldehyde. And the but says 4 carbons. So I'm going to go look for aldehyde with 4 carbons. So aldehyde with 4 carbons, let's quickly first see there. Aldehydes is investigation 1, 4 carbons is going to be there. So 75 degrees Celsius is my aldehyde with 4 carbons. So I can simply go put that answer down. 75 degrees Celsius. Cool. Nice and easy, nothing too complicated. Let's jump to the next question, 3.2. 3.2 says the vapor pressures of compounds A and B are compared. All right, so A and B, we've got, what is this? 1, 2, 3, 4, 5. Sorry, that's 1, 2, 3, 4, 5. So that's pentanol versus 2, 3, 4, which is butanoic acid. How does the vapor pressure of compound A compare to that of compound B? Choose from higher than, lower than, or equal to. So quickly just post in the chat, between A and B, how does A compare to B? Is A higher than, is it lower than, or equal to B? We'll explain the answer just now. All I want you guys to select for now is just say higher than, lower than, or equal to. Thanks, Gamo, for your quick fingers there. Thanks, Boo. Thanks, Timbile. 10 more seconds. Guys, just guess at least. Cool. The correct answer is going to be higher than, right? Why is this the case? Sorry, quickly put this down. Ooh, something is wrong with my pencil. Excuse me. So it's going to be higher than. Why is this the case? Again, um, sorry, how does the vapor pressure of compound A compare to that of compound B, right? So vapor pressure is going to be higher than. Remember, vapor pressure um, is gonna sort of the stronger your intermolecular forces, right? The lower your vapor pressure is gonna be. So in A, you'll have a higher vapor pressure because B has stronger intermolecular forces. Why does B have stronger intermolecular forces? Number one. So yes, A does have a longer chain, but longer chain is useful when we're dealing with like fun with London forces. But remember, London forces, your dispersion forces are the weakest of the forces that we're dealing with. What's more important here is your dipole-dipole and especially hydrogen bonding intermolecular forces, right? So the first thing there is that B is a carboxylic acid, and carboxylic acids, my spelling just went out the window. There we go. Silic acids have two sites for H bonding, right? That's the first thing that's important there, okay? And because that's the case, that means B will have stronger intermolecular forces than A, right? And then when you do that, it does require a lot more energy to separate them there, and therefore A will have a higher vapor pressure than B. Those are the two things that you need to really put that together, right? If you wanted to as well, you can also go and compare the number of molecules in a vapor phase at a given temperature. And again, but the most important thing is the energy needed to overcome the intermolecular forces is the big one there, where more energy is required to overcome intermolecular forces in B. Awesome. Cool. Well done for those that got the answer correct. Give yourselves some awesome celebrations in the chat. That brings us to the end of question 3. Let's jump on to question 4. Okay, let me just move this question up. Okay. Here's question 4. We've got about 20 minutes left. I think we'll get through this question there. So question 4 is going to be as follows. In the flow diagram below, a primary alcohol P is used as a starting point, right? Sorry, starting reactant to form different organic compounds. Okay, so in that case, there are the different reaction conditions. So reaction 1, primary alcohol P creates compound Q. Reaction 2, we create butane from compound Q. Reaction 3, right? We have water and we create compound S. And compound S becomes the major product. Very important. Don't leave that part out there. 4.1.1 says write down the type of addition reaction represented by 2. What kind of addition reaction is represented by 2? Quickly put that down in your chat. We had an alcohol, we had elimination taking place, and then we add something to get butane. So I see everyone saying, please explain 3.2. Okay, I'll quickly do that. Someone also asked for 3.1.4. So 3.1.4, write down the boiling point of butanol. Remember with this one here. So like I said, butanol, the but tells me I've got four carbons, and the null says I'm dealing with an aldehyde. So I'm going to go to my table and I'm looking for four carbons and an aldehyde. So aldehyde and four carbons meets over here. That's where I got that 75 degrees Celsius. It's an aldehyde. These are all aldehydes. And then the number of carbons is going to be four. It meets at 75. That's 3.1.4. 3.2, we had to compare the vapor pressures of these two here, right? Remember, vapor pressure, how I always remember it. Someone's asking, isn't the answer 164? No, 164 would be a carboxylic acid. They're asking for butanol. Butanol is an aldehyde. So I need to go under investigation one, looking for aldehydes. So then aldehyde with four carbons is 75 degrees Celsius, not 164. Hope that makes sense. 164 would be a carboxylic acid, and we're not looking for carboxylic acids there. We're looking for an aldehyde, which is butanol. If it was carboxylic acid, they would have said butanoic acid. Then that would be 164. 3.2 quickly, they said the vapor pressures are shown below. How does the vapor pressure of compound A compare to that of compound B? So the first thing I need, how I remember it, is vapor pressure is always the opposite of boiling point. So I want to first figure out which one will have the highest boiling point, because the highest boiling point will have the lowest vapor pressure. The lowest boiling point will have the highest vapor pressure. So when I'm dealing with this there, A is an alcohol with one, two, three, four, five carbons. B is a carboxylic acid with one, two, three, four carbons. So yes, A does have more carbon chains. It's got a longer chain, but the longer chain is only useful when dealing with like your London forces. But London forces are the weakest forces. So let's look at what the strongest forces are going to be. Dipole, dipole, hydrogen bonding. An alcohol only has one site for hydrogen bonding. So you'll basically have a carbon, whatever the chain comes from before there, OH. And those lone pairs there, right, that becomes a site for hydrogen bonding. But for a carboxylic acid, right, carboxylic acids are going to have that carbon, double bond O, O, H. Note that you're going to have, in this case here, dot, 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 like that there, and then this double bond here. So now you've got this site for hydrogen bonding and that site for hydrogen bonding. And because you've got double the number of sites for hydrogen bonding, automatically carboxylic acids will have a much higher boiling point because they'll have much stronger intermolecular forces. So for every one hydrogen bond an alcohol can have, the carboxylic acid can have the same hydrogen bond from that OH, but also another one from that double bond O, right? Which is also quite critical. So that becomes important. So you have more hydrogen bonding sites, which automatically makes your intermolecular forces way stronger than simply adding an extra carbon, because it's like increasing your strongest type of intermolecular force versus increasing your weakest type of intermolecular force. So that's why your carboxylic acid is going to have the highest boiling point of those two. Highest boiling point means lowest vapor pressure. So your alcohol will have the highest vapor pressure. That's why they said, how do they compare? So A will have a higher vapor pressure than B because B has a higher boiling point than A. That's how I get the higher than. Then the explanation, like I mentioned, carboxylic acids have two sites for hydrogen bonding, like I just showed you there. B will have stronger intermolecular forces than A. Therefore, more energy is required to overcome the intermolecular forces at B. So A will have a higher vapor pressure, essentially. So vapor pressure will always be the opposite of your boiling point. The stronger your intermolecular forces, the higher the boiling point, but the lower your vapor pressure. The weaker your intermolecular forces, the lower your boiling point, but the higher the vapor pressure. Hope that makes sense that for those that wanted 3.2 re-explained. Let's quickly go back and touch on question 4 again. And the question there was, write down the type of addition reaction represented by reaction 2. So again, like I said, we started off with an alcohol. We had an elimination reaction. Usually when you have an elimination reaction with alcohol, you remove an H plus an OH. That's a dehydration reaction. So you end up with an alkane, an alkene. Compound Q will be an alkene. Then I add something to an alkene to get butane. So if I have an alkene, add become an alkane, it means I probably just added hydrogen. So reaction two is going to become hydrogenation, right? I just added um, hydrogen. So basically here, I had to add H2. Okay. 4.1.2, write down the type of elimination reaction represented by reaction one. I already just said that, right? So if I start off with an alcohol and I undergo elimination, usually what I'm going to remove there, I'm going to remove the OH and an H. So I'm going to say minus H2O. When I minus H2O, I've got dehydration. That's us removing H2O from reaction one, adding hydrogen for reaction two. 4.2 says, write down the IUPAC name of compound P, right? So IUPAC name for compound P, let's look at how this would have worked, right? So I would have had an alcohol, removed my H2O. If I add H2, I end up with butane. So if I go backwards, butane minus the H2 gives me butene. Butene plus water will give me butanol, right? So we'll have butanol there. You can write one butanol or butan one, all up to you. Or you can write butan one all. Awesome. 4.3. Consider reaction three. So reaction three is where we take that butene, right? So already, as we're doing this now, let's quickly fill in the things we're saying. So remember we said butane, if you minus the H2, we end up with butene here, right? And then we already said compound P is butanol. Okay. So reaction three, we take butene. With butene, we add water, and then they ask us what is the major product, right? So write down the balanced equation using condensed structural formulae for 4.3.1, right? So condensed structural formulae, we need to look at how that's going to operate. Generally, what I like to do is I like to start with the full structural, and then I'll use that to do my condensed structural, especially because I know that I have to then be dealing and wondering about major and minor products. So I want to draw it out fully so I can see it properly first. Remember, major and minor products, that's where you're following Markovnikov and Zaitsev's rules, right? Markovnikov and Zaitsev's rules state that in an addition reaction, when adding hydrogen, you give hydrogens to the carbon with the most number of hydrogens. In an elimination reaction, when removing hydrogens, you remove hydrogens from the carbon with the least number of hydrogens. Those will always give you your major products. If that reaction doesn't follow Markovnikov and Zaitsev's rules, you end up with a minor product. So let's quickly do that in like full structural formula, and then we can do the condensed afterwards. So that's looking at reaction three, starting off with butene. So reaction three, I've got butene, 1, 2, 3, 4, and there's a double bond somewhere there. Assuming we had butane 1 all, my double bond is going to be towards the end. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I'm going to leave my H's out for now just so I can see where everything else is going to be. Oh, it's fine. Let me just put them in. Because when it comes to my major product, it's very important. Okay. Then we're told that we add water, right? So when we add water, let's quickly do this. So plus H2O. When we add water, what needs to happen? Let's quickly zoom in and see this here. So the next thing here, let me duplicate this. And duplicate my water as well. Oh, that's fine. I'll put the H's in. So when we've got this here, when we add water, there's an addition reaction. I'm going to break bonds. So I'm going to break this double bond there. Oops, it's a bit too big an eraser. I'm going to break the double bond that's here, right? And that will then just be a single bond, and I'll free up a bond here. I'll free up a bond here. Let me quickly just fix these H's and just draw them nicely. So one H is going to be there, one H is going to be there. Now remember what I said about Markovnikov and Zaitsev's rules. I have to add, there's H2O, so I have to add an H, and I also have to add an OH. When adding hydrogen in an addition reaction, I must give the hydrogen to the carbon with the most number of hydrogens. When removing hydrogen, I must remove hydrogen from the carbon with the least number of hydrogens. So in this case, when I add hydrogen, my choice is going to be this carbon, which has one hydrogen, or that carbon, which has two hydrogens. When you give hydrogen, you give to the carbon with the most hydrogens. So this hydrogen has to go there, meaning my OH has to come here. This is my major product. If instead I had done the opposite and I'd given this hydrogen here and that hydroxide there, I have now created the minor product. But the question specified, it said compound S is the major product. So if I want to have the major product, I must give the hydrogen that I'm adding to the carbon with the most hydrogens, which is going to be the end carbon. And then the OH has to then go here. That's your major product. If you had done it the other way around, you would lose marks because that is not your major product. Now that I know what it's supposed to look like, I can actually answer the question and then go ahead and do my condensed structural formula. So that's going to be pretty easy to do that, having drawn everything else out. So condensed structural formula that I've got here, I can then do CH3, that's this one here. Then I've got a CH2, that's that one there. Then I've got a CH, that's that one there. And then a CH2 in that case there. If you want to show where your double bond is, you're more than welcome. You can basically put your double bond here, but you don't have to put the double bond in there if you don't want to put the double bond in there. Plus H2O gives us, and then let's do the last one there, CH3, that's this one here, CH2, that's that one there, CH OH, right? Because it's the CH there and the OH afterwards. That's this one here, and then CH3. And there's your condensed structural formula for that reaction as it takes place. It's 4 marks. You will get marks for that, you'll get marks for that. And then the last one, you get marks for the whole molecule, especially having the OH in the correct place. That becomes important. All right, cool. Super easy, nothing challenging. I'll see if there's any questions. Webinar chat is quiet. My Q&A is quiet. I'm assuming everyone's on the same page with me. If you guys are still with me, please give me a thumbs up in the chat and the emoji. You guys have been quiet for the last 10 minutes, and I'm not sure if you guys are all with me. Give me a thumbs up, any kind of reaction to know that you're still with me and that I can continue. Okay, fantastic. Awesome. Thank you. Thank you for that reaction there. That was question 4.3.1. Right? Then 4.3.2, it says write down the name of a suitable catalyst. There's lots of options here, 4.3.2. Right? Any catalyst for that reaction, you can have sulfuric acid, so that's H2SO4. You can have phosphoric acid, H3PO4. Yeah, I think those two, any one of those two will work in that case there. Someone says, may I please repeat, Queen Moss? Queen Moss, please, sorry, I forgot to mention this rule at the beginning of my lesson. I want you guys to ask very specific questions. So saying please repeat, that doesn't help me to know where you got lost. So you must tell me very specifically what you want me, like what did you understand? And then where did you not understand anymore? So tell me the specific thing you want me to explain again, rather than just saying please repeat. Because I said a lot of stuff in the last 10 minutes when I wasn't getting much interaction. So Queen Moss, I'll give you an opportunity to ask me that question very specifically, and I'll definitely come back and answer it for you. 4.3.1, that's a full question. Where did I lose you? What did you not understand about my description? I'll give you 15 seconds to quickly put that down. Tell me specifically what you didn't understand about 4.3.1. Then at least I can put more emphasis on the part that I might have lost you on. Okay, I'm going to move on in the meantime, Queen Moss, but I haven't forgotten you. Once you tell me specifically what you want me to do, I'll do that. Otherwise, if you just want me to say the same thing again, the session is being recorded. You can just go watch the recording on our YouTube tomorrow, and then you'll hear me say it again. But I want you to tell me what specifically you didn't understand, then I can maybe try say it differently or try explain it further for you. Okay, that's really why I'm doing that, not because I don't want to answer you. Okay, awesome. That's 4.3.2. Let's look at 4.4. Quickly try to do this before 8 o'clock. We're told here that butane can be converted to compound P in a two-step reaction. Use structural formulae to write down the balanced equations for these two reactions. So butane can be converted to compound P. Let's quickly go look at what's compound P. Compound P is butanol, right? Let's go look at what those two steps can be for us to then be able to get butane. So in our two-step process, what we will do, we start off with, sorry, is it butane from compound P or to compound P? Can be converted to compound P. So we start with butane, and then we must end off with compound P. So let's quickly have a look at that. And then in a two-step process, that's 4.4. So 4.4, we start off with butane. That's 1, 2, 3, 4. Hydrogens everywhere. Okay. Now, in a two-step process to get to compound P, which is butanol, right? What I'm going to start by doing is I'm going to start by having a halogenation process. It's going to be a substitution reaction of halogenation. And then I'll do another substitution reaction again after that, right? A hydrolysis process. So for halogenation, what I'm going to do is I'm going to add any kind of halogen. You can specify bromine, iodine, whatever. In this case, I'm going to just leave it as X2, just a random, just halogen. And when that happens there, I will then form the product that looks as follows. Okay, so we'll have that there, except one of my halogens is going to swap places with one of my hydrogens. So we'll put one of our X's here. Plus we'll then have HX, a hydrogen halide, for that substitution reaction. That's step one. Step two, I will then take my my haloalkane, and then I will do another substitution reaction, right? A hydrolysis substitution reaction with water, right? So in that case there, I'm going to add H2O, in which case my OH will swap places with my halogen. Though in this case, I will have specific reaction conditions that are required. So there, I need to use a concentrated strong base, right, as part of my reaction conditions. So in this case here, I do need concentrated strong base. Think about strong bases. Strong bases are going to be group 1 hydroxides, lithium, sodium, potassium with a hydroxide. So I can either have Li, OH, you can have potassium hydroxide, you can have sodium, Na. OH. Any one of those ones there. Concentrated strong base, you know you're good there. And then that can also be in place of the water, by the way. Sorry. So instead of you can have that instead of the water, you can put that that strong base there. And then the OH from either the strong base or the water will swap places with the X. And then what's going to happen there is this will happen. Duplicate, put that there. And then our final product there is the OH from the H2O will swap places with this X, and you'll have your OH there. And then that halogen, that X, comes off and joins the H from the other H2O, and then you end up with just HX. But if you had used sodium hydroxide or lithium hydroxide or potassium hydroxide, you would end up with a product of sodium with the thing. You end up with NaX with the halogen, or lithium with the halogen, or potassium with the halogen as a product. But other than that, you'll have the HX. That's the two-step process we can follow. So instead of just doing that process that we had before, I can start with my butane, right? I can add a halogen, and then one of my halogens takes the place of a hydrogen, and then I end up with this haloalkane. The haloalkane, I keep the same thing there, react that with water or a strong base, sodium hydroxide, lithium hydroxide, potassium hydroxide. Any one of those, then the OH from there, or even from the water, swaps places with my halogen. So that halogen that we see here swaps places with the OH, and now I've got the alcohol I was looking for, that butane-1-ol or that 1-butanol. And then my final product there is also HX or NaX, LiX, or KX. Keep in mind, X is not necessarily an element by itself. X just represents any halogen. Could have been fluorine, iodine, fluorine, any one of those, bromine, any one of those things there. Okay, hope that makes sense. I know it's 8 o'clock. Can I quickly just finish 4.5 and then I'll release you guys? It's just 3 marks. It'll be pretty quick, right? So 4.5 says, write down a balanced equation using molecular formulae for the complete combustion of butane. Super easy, nothing crazy there. Butane, that's going to be 4 carbons. That's 4.5. So 4.5, we need the complete combustion of butane. So butane is 4 carbons. That's C4H(N plus 2, which is H10, plus oxygen. We need oxygen for combustion. Gives us carbon dioxide and water. And we have to balance this reaction out, right? So in order to balance this reaction out, let's quickly have a look there. So on the left-hand side, I've got 4 carbons there, and I only have 1 carbon on the right-hand side there. So what I could do is if I put a 4 here, I now have 8 oxygens, right? 8 oxygens, that's only 2. So if I put a 4, my oxygens and my carbons are balanced. Hydrogen, I've got 10 on the left-hand side, but only 2 on the right-hand side. So if I put a 5 here, now what I've done is I've increased my oxygens as well. But notice the one thing. I've increased my oxygens by an odd number. So if I have 5 oxygens here, I'll always have an odd number on the right-hand side. And the left-hand side is O2, which will always be an even number. So I can't do 5. So in a case like that, what I have to do is double that 5 into a 10, so that I always have an even number. So now that I've done that, I'm going to change a lot of my other values as well. So if I've doubled that, let's quickly go back. I've got 20 hydrogens. So to have 20 hydrogens, I need to balance those out by putting a 2 here. That's going to be 20 hydrogens on the left-hand side. That changes my carbons. 2 times 4 gives me 8 carbons. So I change this 4 to an 8. Let's look at my number of oxygens. Oxygen is going to be 8 times 2, which is 16, plus 10, which is 26. On the left-hand side, I've only got 8. So to get 26 divided by 2 will give me 13. And that should balance everything out because my oxygens will be 26, oxygen 16 plus 10, 26. Carbon, I've got 8 on the left-hand side, 8 on the left-hand side. Hydrogen, I've got 2 times 10, which is 20. Right-hand side, 10 times 2, which is 20. My equation is completely balanced. Okay, awesome. That brings us to the end of today's lesson. I'm going to pick up from question 5 tomorrow evening at 6 p.m.